You are welcome to the course Atomic and Molecular Physics. So, in this course basically it is designed for undergraduate students of science and engineering. So, who are pursuing BSc degree in physics, chemistry, electronics, material science, and also BE or BTech degree in engineering physics, chemical engineering, engineering in metallurgy, electronics, optoelectronics, cryogenics. So, for those students this course will be suitable. So, this course content basically so we have divided this content into 12 weeks. So, week wise I have given the list where you can see that in week 1, so we will cover the experimental observation and theoretical prediction of constituents of an atom, basically historical background of the development of the subject. So, that we will cover in week 1, and in second week we will discuss about Sommerfeld model of atomic structure, and then we will go for quantum number and vector model, quantum mechanics and hydrogen atom, then effect of electric and magnetic field on atomic spectra. So, that we will discuss. Then selection rule, this basically transition of electron from one energy level to another energy level and corresponding spectral lines. So, there are some rules, all lines we cannot see. So, that we will try to explore, and then alkali atom and atomic spectra, then many electron system. So, these up to 8 weeks. So, we will basically learn about the atomic structure and atomic spectra, and then next 4 weeks we will learn about the molecule. So, this in week 9 rotational spectra of molecules, then vibrational spectra of molecules, next electronic spectra of molecules, and then we will summarize this molecular structure and spectroscopy. So, these are the more or less course plan for atomic and molecular physics. So, for this course I have given reference of 5 books. So, that first one I have given this Physics of Atoms and Molecules by Bransden and Joshen. Next one, Fundamental of Molecular Spectroscopy by Banuel and McCash. Then Introduction to Atomic Spectra by White. Next one, next fourth and fifth one basically it is written by Gerhard Herzberg. So, one is atomic spectra and atomic structure, and another is molecular spectra and molecular structure. So, these 2 books basically this atomic and molecular physics is described physically, not much mathematics is used. So, for physical understanding this 4th and 5th that book are very useful. So, atomic nature of matter and constituents of an atom. So, now we know about atomic structure and its constituents. But if you think, just if you close your eye and go 2005 years ago, so what was the situation in that time? So what I want to mean that now we know all matter in universe are made of atoms. An atom is neutral, and atomic constituents are electron, proton, neutron. Now, how this atomic nature of matter and constituents of an atom, so to know this information, it took 2005 years. So how it has taken, how this was known to us. So what is the historical background? So that I will try to explain first. So atomic nature of matter. So in 500 BC, before Christ, means from now it is around 2005 years ago. So this philosopher from Greek, you know this, in Greek there are many philosophers, and Democritus and Aristotle, they thought about the matter, whether matter is made of discrete particles or the matter is continuum. So that they started to think about the nature of matter, and Democritus, he was in favor of the discreteness of the matter, means matter is made of discrete particle, whereas Aristotle, he support the concept of the continuity of the matter. So matter is continuum. So that was the beginning of thinking about the nature of matter, and after long gap, the question was reopened following the experimental observation. So that historical development was basically started from three directions. One is kinetic theory of gases, another is chemical composition or combination, and other one is light spectra. Okay. So this in 1662, in this year the discovery of Boyle's law. So you know Boyle's law, that volume and pressure, they are inversely proportional at a particular temperature, right. So that was the basically experimental observation, but why it happens, that was not known. This explanation of this result was not known. So it took long time to understand why such type of relation followed by gas. So for interpretation of this law, kinetic theory of gas was developed throughout the 19th century, okay, by Clausius, Maxwell and Boltzmann. So the postulates or assumptions for kinetic theory of gases was basically that all gases are made of a very large number of particles called molecules, and the size of the molecule is extremely small compared to the intermolecular distances, right. So, that was one first assumption. Second assumption was the molecule are considered rigid and perfectly elastic spheres. Third assumption was for a particular gas, all molecules are identical in all respects, means its mass, its size are same. Okay. So, that was considered, that is the postulate, that is the assumption. Okay. So, considering this assumption, then some mathematical derivation or relation was established, okay, and that mathematical relation will agrees with the experimental result. So, generally for any theoretical calculation, we take model and build up the theory, expression, equation, etc. And then if that theory, that expression, equation, if it fit with the experimental result, then we tell that the assumption whatever we made for this model, they are correct. Okay. So, that is the normal procedure. So, in kinetic theory of gases, basically concept of molecule, concept of discrete nature of matter was considered and theory was developed, and that theory basically this the law of velocity distribution, which sometimes we tell Maxwell's velocity distribution of gas molecules. Okay. So, that distribution, velocity distribution, that was very successful to explain not only the Boyle's law or Charles' law, it was successful to explain the origin of temperature, pressure, thermal conductivity and viscosity of the gases. And the as I told that this theory was able to explain the experimental observations like Boyle's law, Charles' law of gases. So, the atomic nature of matter was confirmed in the 19th century from the direction of kinetic theory. So, that is this is one direction. From other direction also this similar type of conclusion was made. So, that was the next. Another one is from chemical combination. So, around 1800 AD, so based on many experiments, laws of chemical combination was discovered. What are those laws? There is conservation of mass, means in chemical reaction the total weight of all components taking part in the reaction is equal to the total weight of all product of the reaction. Okay. So, before reaction, whatever the component, individual components, so they react, and then after reaction we get product. So, mass of the components before reaction, total mass is equal to the total mass of the product after reaction. So, that was one experimental observation which generally we tell this laws of chemical combination. Second one was law of definite proportions, laws of definite proportions. So, in chemical reaction the total weight of all components, taking part in the reaction is equal to the total weight of all sorry. So, that was the basically conservation of mass, but laws of definite proportion, that that is basically when two chemicals or elements A and B combine to produce a chemical C. So, before reaction individual element A and B, when they combine, they after reaction they produce a chemical C. So, then the element A and B are always present in a definite proportion by weight in C. Okay. So, chemical A, chemical B, they react and they produce C. Now, the element A and B, they are present in C, that is they are in A and B, they in any proportion, in any amount is not allowed to form the product. So, they have to combine in a definite proportion to get the product C, okay, or in product C A and B are in definite proportion, it is not arbitrary. Okay. So, that was the law of definite proportions, and third one is multiple proportions. Multiple proportions, when A and B combine chemically to produce two or more chemical compounds, say C1 and C2, then the ratios of the weights of say B, which combine with a fixed weight A to form C1 and C2, are equal to the ratios of small integers. Okay. So, what does it mean? Say example, if you take carbon, say it is A, and oxygen it is B. So, when they combine, so it can form, the product can be carbon monoxide CO or carbon dioxide CO2. So, C, that is fixed one, is A basically. So, combine with B, form the two product. So, this B, the weight of B, that is basically weight of B combined with A. So, that ratio of B is basically very is a small integer. So, again it is telling that is called multiple proportion. So, one is fixed and another is, if it is another combined to the fixed one and form different products, and in different products the amount of B in which ratio they are. So, that is telling their ratio is in is of simple is small integer. Okay. So, this was the experimental observation, chemical combination. So, how to explain them? So, that basically that was done by Dalton's. So, in 1808, Dalton's hypothesis of atomic nature of matter successfully explained the laws of chemical combination. Okay. So, you know what is Dalton's hypothesis. So, Dalton's hypothesis is basically the matter are composed of discrete atoms. So, that was the first hypothesis. Second one, for a given matter, these atoms are all identical and each atom has the same weight. Third one was compounds are formed when atoms of different matters combine in a simple ratio. Okay. So, these are the three hypotheses, Dalton's hypothesis, and clearly from this hypothesis you can see it is telling about the atomic nature of matter, and in the matter how this discrete particle, how these atoms combine with the other matters, other substance, and so from this combination basically we tell that this is the first attempt of Dalton to tell clearly that the matter is made of atoms and these atoms are indivisible. It cannot be divided, it is not breakable, it cannot. So, this is the smallest unit as if. So, these atoms are indivisible. So, this was the first discovery in science. Generally this we taken as a first discovery of atomic nature of matters. Matter is made of atoms. That time it was still Dalton did not know about the constituent of an atom. Okay. So, he considered this atom is the smallest particle and it is indivisible. Okay. So, I will stop this lecture here and then I will continue the next part in next class. So, thank you.